Let's try multiplying the two hexadecimal numbers DF times BC, and we'll use our multiplication table, our hexadecimal multiplication table that we showed in the last video. So if we write this out, DF times BC, what we have to do is we have to do C times F, and we have to do C times D. So C times F, we can look that up either way, but we'll do C times our F here, and that's a B4. And we can do C times D, and that's a 9C here. And then we're also going to have to do B times F and B times D. So in the meantime, we can go through our B column and we can find these two products as well. So these are the numbers we'll have to work with, but then we're going to have to add them. So once we do our C times F, we get the B4. So we're going to put down our 4 and we're going to carry the B. So when we do C times D, that's 9C, but we got to add B to that. So when we add B, our B plus C, well, that's not obvious. B plus C, that's our hexadecimal. B is a decimal 11, so we get our 11 plus 12 base 10 is 23, and then we can convert that back to hex. Converting that back to hex, that 23 is our 16 minus 7, so we get a 1/7. So the B plus C base 16 or hexadecimal, that's equal to a 17 base 16. So that 17, we can put down that 7, but then we have to add that to the 9. So we add 7, and then our 9 plus 1 here, right? The 9 plus 1 gives us the A. So A7, 4 is what C times D4 is equal to. So now let's do the next row. We do our B times F and our D, our B times D. So our B times F, that's A5. So we can put down the 5 and carry up the A here. So when we do our B times D, that's our 8F, but we have to add A to that. So our F plus A, that's a 15 plus 10, so that's 25 base 10, which gives us our 19 base 16. So that 19, we can put down the 9, we got to carry the 1, and our 1 plus 8 is 9, so the 99 is what goes here. And then we need to add those all up. So when we add those all up, we get our 4. 4 just comes down. 7 plus 5, that's equal to 12. Well, a 12 is our hexadecimal C. And then we get our A plus 9, that's a decimal 19, which is a hexadecimal 13. So we have 3, carry the 1, and 1 plus 9 is 10. That's a hexadecimal A. We get our AC34. So that's our process. We can do that in hexadecimal using our decimal conversion to do the additions and using the hex table to do the multiplications. We can check it. We can check it by converting these then first. If we convert our DF to base 10, our DF base 10 then is equal to our D. That's our D is what? Our D is 13. Yeah, so it's 13 times 16 to the 1 plus 15 times 16 to the 0, which is just equal to 1. So that's 13 times 16 plus 15. You can put that in your calculator, but that's 223. Whereas our BC, converting that to base 10, and then again, these are base 16. This is, so we'll write down here, this is base 10. Our BC, a B is 11 times 16 to the 1. We'll just write 16, plus our C is 12, and that's equal to 188. So if we multiply these two numbers, then we get our 41,924. So now we need to check this. This number here is going to be 10 times 16 cubed plus 3 times 16 squared plus our C is the 12 base 10 times 16 plus just 4 times 16 to the 0, so that's a 1. that's just equal to 4. And you can check that. That's also equal to 41,924. So we could have converted first to decimal, done the multiplication, and then converted this back to base 16. But that's not what we did. We checked it this way, but the way we did the multiplication is we went back, we used our multiplication table to do the original multiplications of C times F and C times D, for example. But then when we did the carry, when we add back up in hex, we did convert to decimal to get our decimal equivalent and converted that back to base